Okay, last one. Finally, the end of Are You Ready for Calculus, number 36. Okay, and they want you to prove some of these basic theorems. That we did all these already in trig, so this is good review. Okay, so first of all, we wanted to derive first theorem. So we just basically we wanted to come up with a Pythagorean identity over here. So all we had to do was just use the cosine of the sum and then call this negative x and then put this right in our cosine formula. Remember the cosine formula was cosine, cosine, sine, sine. Okay, so that was real straightforward. So all we're going to do is add x to negative x. All right? So we have, when we put this in the cosine, cosine, sine, sine, we have the cosine of x, cosine of negative x, minus the sine of x, sine of negative x. But remember, the cosine of negative x is just the cosine of x, because they're both in the first and the fourth quadrant, and that's where the cosine is positive. So these are the same, but the sine of negative x is negative the sine of x, so that changes this. So this is negative the sine of x. I put my negative times the negative as a positive, and the cosine times the cosine is the cosine squared of x. Sine times the sine is the sine squared of x, and there you have it. Sine squared plus cosine squared equals 1. Now these are the two angle formulas which are very important. We use these a lot in calculus to reduce situations so we can work with them easier in some areas of calculus. I won't go too much into that right now. So basically we want the two angle formula. We want to show this. So basically this is derived from the sum. Remember sine, cosine, cosine, sine. When we take the sum, and it's the same SIGN, same sign. So sine of x, cosine of x, plus the cosine of x, sine of x. But these are the same, aren't they? I just can reverse that. So I got two of these, so there we go. So that's all you had to do was for letter B. Letter C, the same idea. These are the two angle formulas for the cosine. And again, we just say the cosine of x plus x is the cosine of 2x. And we put this in our cosine sum formulas, cosine, cosine, sine, sine. Different SIGN. So this would be the cosine of x minus the sine of x, and that's just the cosine squared of x minus the sine squared of x. Okay, so those are our basic two angle formulas, and from these we can derive the other forms of the two angle formulas for the cosine. There's three forms, and we do use these, so you can derive them all from this cosine two angle formula, and then using our Pythagorean identities. So if we want it in terms of cosine squared, all we have to do is write the cosine of 2x equals this. And then instead of writing the sine squared, I know that sine squared plus sine squared plus cosine squared equals 1. So if I want to write this in terms of the cosine, I can write sine squared equals 1 minus the cosine squared. And then instead of writing sine squared, I write 1 minus the cosine squared. So I get this identity from the Pythagorean. So I just make that substitution. Then I remove the parentheses, so I've got negative 1 plus cosine squared, and I got a cosine squared and a cosine squared, so I got two of them, minus 1. So that's how we derive that. Okay, it's pretty straightforward algebra. And then we want the cosine in terms of the sine, the cosine of 2x in terms of sine, so basically it's the same idea. I start again with this basic identity which comes from this one. See, so we start with this, we get this cosine 2x, and then I want everything in terms of sine, so instead of writing the cosine, I know that the cosine squared of x equals 1 minus the sine squared of x. So instead of writing this, I write 1 minus the sine squared of x, and then I have minus the sine squared of x, so I got 1 minus 2 of these, so 1 minus 2 sine squared of x. So that's not too bad either. All stuff we hopefully learned in trig. Now we have the half angle formulas, and all you have to do is take either of these two formulas and then just substitute. So this was the one we got in letter D, and all we have to do is replace x by x over 2, and we've got it. So this was what one we just derived in letter D. Cosine of 2x equals 2 cosine squared of x minus 1, and then instead of writing x, I write x over 2. So this is 2 times x over 2, and this is the cosine squared of x over 2 minus 1, two of those. What's 2 times x over 2? That's just x. So all I did was simplify this. Then I added 1 to both sides. Then I divided both sides by 2. And then I take the square root of both sides. And usually we see it in this form. Cosine of x over 2 equals plus or minus the square root of this cosine of x plus 1 over 2. But for some reason they wanted the absolute value, so we write it like this. We just take the absolute value of both sides. If I take the absolute value of the plus or minus, it's always going to be positive, so that takes care of the plus or minus. And the last one, we'll do the same thing, except we're going to use letter E. This one is what we derived in letter E. And again, we'll replace x by x over 2. So the cosine of 2 times x over 2 equals 1 minus 2 sine squared of x over 2. So that's, again, just x. This is the same. And then I'm going to take the square root so I don't have to worry about the negative. I'll put this on the left, so I'll add 2 sine squared of x over 2 to both sides, and I'll subtract cosine for both sides. And then I'll divide by 2. And then I'll take the square root of both sides as I did before. So again, divide by 2. And then take the square root of both sides. Then take the absolute value of both sides. And you're done. And remember, you could always pause these if you want. And I think I have enough pictures there so you can get the gist of everything. Okay? So that's Are You Ready for Calculus? Make sure you know how to do all these. We'll try to have some kind of test the first week of school on all this material. So I make sure that you've gone over and have a good comprehension of all the skills that they kind of ferret out. Okay? And then we'll have some other assignments also.